In this presentation, we are going to look at a couple of topics in descriptive statistics. We are going to look at the 5-number summary. We're going to revisit the interquartile range. We're going to look at the mid-hinge, and we are going to look at the trimean. So the first thing we're going to look at again is the 5-number summary, which is a descriptive statistic that provides information about a set of observations. It consists of the 5 most important sample percentiles: the sample minimum, the lower quartile or first quartile, known as Q1, the median, the upper quartile or third quartile, Q3, and also the maximum. So, suppose a sample has the following 5-number summary. That's an example of a 5-number summary, and I'm going to use these values later on. So it's just a sort of kill two birds with one stone. Present a 5-number summary here, and also some data I'm going to use later on. So the sample minimum here is 11, Q1 is 25, median is 27, Q3 is 31, and the sample maximum is 38. So, next we move on to the interquartile range. It's a measure of statistical dispersion being equal to the difference between the first quartile and the third quartile. So it's Q3 minus Q1. So for the our data we're going to use, the third quartile is 31, minus 25, that's the Q1. So the difference between the two numbers there is 6. So the interquartile range there is 6. Just a quick remark, the corresponding measure of location or central tendency is the median. They would be sort of go hand in hand, the median and the interquartile range, as measures of central tendency or location and dispersion respectively. Okay, so what we're going to do now is look how we would use the interquartile range in outliers. So the interquartile range is often used to find outliers in data. For example, using this approach, and just to sort of remark, there are other approaches that may not yield the same results as this approach. So I'm underlining that using this approach. Outliers are observations that either fall below the lower fence. The lower fence is Q1 minus 1.5 times the interquartile range, or above the upper fence, which is Q3 plus 1.5 times the interquartile range, IQR. So any value outside of those fences are considered outliers according to this technique. There are other techniques where we might get different answers, but according to this technique, we'll just proceed. So the lower fence for using our data, Q1 is 25. 1.5 times the interquartile range, that's 1.5 times 6, that's 9. So what we have here is 25 minus 9, and that is equal to 16. So any value less than 16, and in this, for our data, the sample, the minimum value is 11, is considered an outlier. So we will consider 11 to be an outlier in this data set according to that method. There could be other ones as well. There could be a 12 there in the data set that we don't know about, but 12 or 13 or so. And any value like that would also be an outlier. Okay, let's look at the upper fence. The upper fence is Q3 plus 1.5 times the interquartile range. Q3 is 31, so we have 31 plus 1.5 times 6, that's 31 plus 9, which is equal to 40. So any value greater than 40 would be considered an outlier, but as the maximum value of the dataset is 38, there can be no high value outliers, because essentially the highest value is 38, so it has to be greater than 40 for it to be an outlier. So in that case, on the high side, there are no outliers. Okay, so that's how we might use the interquartile range and to determine the fences. The next thing we're going to look at is the mid-hinge. This is a measure of central location or central tendency, and it's determined as the average between the first quartile and the third quartile. So rather than the difference between the two, what we're going to do is get the average of the two. And in this case, the mid-hinge would be 28. So it's 25 plus 31, that's 56. Divide that by 2, so 56 divided by 2. The mid-hinge here is 28. Okay, so that one's straightforward enough, actually. Lastly, what we're going to do is look at the trimean. So this is a measure of central location, also defined it as the weighted average of the distribution's median and two other quartiles. So we have Q1 plus 2 times Q2, that's the median, plus Q3, and divide that by 4. So we're counting the median twice. Just as a remark, it's actually equal to the average of the median and the mid-hinge. This is the mid-hinge here, if you recall. So that part there. Now, so let's look at our data set here again. So we have 25 plus 2 times 27 plus 31. That's divide that by 4. So we have 110 divided by 4, and that's 27.5. Just as a remark, let's do it the other way, median and mid-hinge. So median plus mid-hinge, divide that by 2, we get 27 plus 28 all over 2. That's 55 over 2, and that gives us the answer up there, 27.5. So you can use either approach there. Anyway, that ends our presentation. Thank you very much.